Homework problems 1A. What is the volume in liters of 2.5 moles of oxygen gas measured at 25 degrees Celsius and a pressure of 104.5 kilopascals? Probably one of the first things you want to do is ask yourself, well, what is the question? And there's my question. So that means that I am looking for the volume, and in this case in liters. I have my 2.5 moles, which is my variable N, of oxygen gas. That really isn't significant in this problem, but it's measured at 25 degrees. So I'm going to add 273 to that, 298. And a pressure, which is our T value, and at a pressure of 104.5 kilopascals, which is your pressure. Okay? So obviously, we have a pressure, we have a gas situation, so we're going to use PV equals nRT. And what we want to do is we want to rearrange all of the known variables, or the values that we know, to one side and leave the one value that we don't know to the other side. So that means that I'm looking for V, so I want to get N, R, T, and P on the same side. So that means I'm going to divide by P on both sides. So now my equation looks like this. E equals nRT over P. Okay. So once I have that, make sure I plug in the right values. So my number of moles is 2.5. My R value, okay, now I have a pressure, so I have to use the appropriate R value, which in this case is kilopascals. So I'm going to use the kilopascal value, so 8.315 liter, put the mole Kelvin. Okay. And my temperature, I believe was 298, yeah, 298 Kelvin. And my pressure, 104.5 kilopascals. So let's look at the units that can cancel. So moles are gone, kilopascal gone, Kelvin gone, and the unit that I'm looking for, liters. So that's a good thing. So we have our problem set up correctly. Type all that in and I get 59.3 liters. Yeah. All right, so let's take a look at, here, I'll let you look at that for a moment. So hopefully you can see all of that. So again, always identify what your question is and then assign the variables accordingly. Be sure that you are showing this process here. Always show the variables rearranged. Now again, if you can do that in your head, you don't have to show that on paper, but it sure does make it a lot easier for yourself. And then of course show your answer. All right, let's take a look at 1C. Okay. So 1C, again, it reads, what is the volume? So there's our question. And it's in milliliters this time. So what is our volume? Of a 3.6 moles, which is our N of argon gas. Argon, this isn't significant yet. At a temperature of 35 degrees, so add 273, which is 308, which is our temperature, and a pressure of 2.2. Okay, so again, it looks like we're looking for the volume. So PV equals nRT. We are isolating V, so that means we need to divide P on both sides. So our equation is this. And let's plug in our values that we know. So we have our number of moles, which is 3.6. 3.6 moles. R, this time we have atmospheres. So we have to use the atmosphere value. So 821. Atmosphere liter. Put the mole Kelvin below it. And the temperature was 308. And our pressure 2.2 atmospheres. Okay, so let's look at alike terms, or cancel out alike terms. So moles can go away, atmospheres can go away, Kelvin can go away, and we're left with liters, which is our volume. But the question wants it in milliliters, but we can't change it yet until we get our volume value here. So when I type all this in on the calculator, I get 41.4, and that is in liters. So to do the conversion, liters and milliliters, which one's bigger? The liter, so assign it to value 1. We have 1,000 milliliters in there. So when I multiply that, I get 4.14 times 10 to the 4 milliliters, or it's 41,400 milliliters. Let's take a look at that one.